I'm fine, sir.
Fine. Okay. Asta is here. Samaya is also here. Hi, Asta. I'm really sorry I could not take your class on Monday. I'm like literally now also very much swamped with my research work. Okay. So I get time only on Sundays.
Yes, sir. No issues. Just let me know whenever like you get time, or even on the weekdays, and we'll try to complete because the exams are coming up next month.
Re-exam.
Yeah, half yearly exam for
Half
grade.
yearly exams, right?
So we have to complete that.
Okay. So Sunday you have schools, right?
Yes, sir. We have Friday, Saturday holiday, and rest of the week school.
Rest of the week. So like for tomorrow, is it a holiday tomorrow?
No, tomorrow is Wednesday, no?
No. I mean, in India we have Ganesh Chaturthi. So I was thinking maybe. Do you
No,
get
no.
No. Okay. What holidays do you get then?
So we get holidays for the major holidays are for like Eid and all. The Muslim festivals more priority is obviously given here, and like Diwali maybe 1 or 2 days, Independence Day 1 day, and like that only 1 2 days.
So Durga Puja and all, Durga Puja you did not get. You will not get holiday on
No,
Durga Puja.
no, we don't
Oh, okay. Diwali even in India, they give only 1 or 2 days. Durga Puja is a bit stretched if you go to Bihar, Jharkhand, and West Bengal belt, and even in Chhattisgarh or Odisha, that belt. Then Ganesh Chaturthi is like in the Maharashtrian belt, small common there. In Delhi, I was there. Delhi is also like they don't give holiday any for anything. Even for Diwali and all, they give only 2 days holiday or 1 day holiday. Okay. Do these questions. Let me know when you're done. Samira, I saw your assignment. Okay. So I see that you have not done the last question. Do you identify the reagent, Samira? Samira, am I audible? Hello? No. Can't hear you, Samira. Can you please write in chat whether you can hear me or not?
Yes, sir, I can hear you.
So can you identify the reagent that the last reagent you have not done for H2CrO4, I think, right? In the
Yes, sir.
assignment. Okay, so what type of reagent is that? H2CrO4? We have seen that reagent before also, no?
Yes, sir, in that oxidizing agents.
Correct. So oxidation is happening of phenol, correct?
Yes, sir.
And we have done oxidation of phenol. We have seen a reaction, right?
So, but it only happens on primary carbon, right?
नहीं ऑक्सीडेशन ऑफ फिनॉल देखिए एक टॉपिक है we have done ना ऑक्सीडेशन ऑफ फिनॉल नहीं हमें तो लग रहा है किया हमने
I don't think so. The last two questions were there in the recent, in the notes we have done.
जिंक डस्ट वाला किया था हम लोगों ने है ना नहीं एसिडिक कैरेक्टर ऑफ सब्स्टिट्यूटेड फिनॉल डिड वी डू जिंक डस्ट वाला क्या था कि नहीं किया था अगर नहीं किया तो
Sir, we
देखो
did it.
Zinc dust we have done.
कहाँ गया लेकिन why can't I find it acidic character of substituted phenol 25 अगस्त फिर 23 अगस्त फिर 18 ठीक है chemical properties acidic character of phenol if we have done zinc dust then we should have done that also oxidation of alcohol oxidation of phenol after zinc dust किसका खुला हुआ है B5 खुला हुआ है
Yes, we did, sir.
oxidation of phenol किया ना हमने
Yeah.
can all of you see just after zinc dust
Yes, sir.
is there हाँ देखिए ये तो रहा हम घबरा गए बिल्कुल हम तो सी देखिए ये भी यहाँ पे क्या है व्हाट इज दिस is the oxidizing agent Na2CrO4 Cr2O7 correct and
Yes, sir.
H2CrO4 is also oxidizing agent so you can just write the same product here benzophenol
Okay, sir.
I think now let me see your answers oh just a second okay benzoquinone I think please correct it now I've mistakenly written a circle there benzoquinone has a structure like this okay please correct it my bad जल्दी में हमने वो कर दिया होगा ठीक है अब ये सारे प्रोडक्ट्स हैं ये तो हम देखेंगे ये खालिद का असाइनमेंट अच्छा खालिद अभी भेजेगा अच्छा खालिद तो पहले देने का असाइनमेंट था ओके आई थिंक द लास्ट क्वेश्चन ना लास्ट क्वेश्चन हम नहीं किया होगा हो सकता है हाँ लास्ट क्वेश्चन हम लोगों ने नहीं किया था ठीक है जो
That's,
आपके
I
पास
guess,
वीमर रिएक्शन है ना वो हमने नहीं किया था कोल बेस तक किया था हमने सो डाइल्यूट HNO3 in dilute HNO3 what is going to happen you will get two products all of you those who have written one product please change it to two products you will get O-nitrophenol and you will also get P-nitrophenol Then for concentrated HNO3, you will get one product, that is tri-substituted trinitrophenol, OH, and NO2, NO2, NO2. In Br also, since we have here non-polar solvent, I will get two products, ortho-substituted and para-substituted. But if there was water or ethanol, then we will be getting it, because they are polar, we will be getting one product, which is tri-substituted bromophenol. Now here we have dilute HNO3, and in this case you have this particular position which is also active, but it is unreactive due to the steric hindrance of CH3OH, and that is why you will be making here OH, CH3, and one NO2 here, ortho to hydroxy, para to CH3, plus we will be making one more product, because dilute HNO3, it is not it is mononitration. That means you will have to make all the possible products. So here I will be getting OH. We have done this in the last class, by the way. And here I will be getting NO2. The last reaction is, see, the first step will be giving you ONA. The second step will be giving you OH here and COONA here. And the last step, that is H+, that will be removing this Na, and it will be giving you salicylic acid, okay? COOH. Okay, so please write this down. Let me know when you're done. If you have any doubt in any one of them, please ask me, okay? And, okay, so just Reamer Teeman is remaining, and like next class में आपके chapter ही खत्म हो जाएगा, most probably. Ethers का majority of the parts आज ही हम करा देने की कोशिश करेंगे. चलिए. All right, next Reamer Teeman reaction. Okay.
Sir, could you scroll up a minute?
Yes, sorry, tell me.
Sir, could you go up again?
कौन सा reaction number बताइए, please.
Done, sir.
Just take a screenshot, है ना?
Yes, sir.
Take a screenshot, okay. Also try to come on time.
Done, sir.
Okay. Walaikum Assalam, Muhammad Umar. After a very long time, how are you? Oh, nice. So did you watch the lectures, the previous lectures, Muhammad Umar? Okay, in Reamer Teeman reaction, please start writing. Start writing, and then after that we will explain it, okay? When phenol is refluxed with chloroform in the presence of aqueous NaOH, in the presence of aqueous NaOH at around 320 Kelvin, I think it is 340 Kelvin.
Sir, is that refluxed?
refluxed. I will explain everything. Write this. When phenol is refluxed with chloroform in the presence of aqueous NaOH at around 340 Kelvin, followed by hydrolysis, an aldehyde group gets introduced. An aldehyde group gets introduced. Get introduced at ortho position. Of phenol. Ortho position of phenol leading to formation of salicylaldehyde. Okay, then you have to cover a lot, by the way, Umar. You have not start watching. If you have doubts, then just let me know on WhatsApp. Okay. Start watching, but okay. So first of all, please, right? What is the first reaction when phenol is reflux? Reflux means we boil it, and when we are boiling it, now the vapors that are there that are coming again back to the same liquid. So we are not letting the
Sir?
vapor escape. Sorry, tell me.
Can you hear me?
I can hear you.
Okay, fine. I was just checking if you can hear me or not.
Wow, very good. Say, बहुत सही. ठीक है, I can hear you. Thank you. Okay, so reflux means that when we are boiling, okay, it's simple boiling, but whatever the vapor is there, we are dropping that vapor, and that vapor is again used in the chemical reaction. Okay, so when we need something which is of very low boiling point, some liquid which is of very low boiling point, but we need the vapor of them. So what do? We mix both the liquids, liquid A and liquid B. In that case, liquid B will be having lesser boiling point, and we want to have the liquid B in the vapor form for the reaction. So we mix them and then we start heating. So obviously, when we are heating, the B1, which is having lower boiling point, it will boil first, it will go to vapor, and then the reaction happens. Okay. So just right when phenol is refluxed, obviously here phenol will be having high. When phenol is
Sir?
refluxed, tell me.
So what does reflux means over here?
अभी तो बता रहे थे, अभी हम क्या बता रहे थे, बताइए आप. Yes, Umar, what I was saying.
Understood it.
What did I say? ये बताइए ना, हमने तो आप कंप्लीट भी करने नहीं दे रहे थे हमें. हमने क्या बताया वही तो बता दीजिए कम से कम.
I don't remember.
हाँ, तो ध्यान से सुनिए. We have to boil something, and whatever vapor we get when we boil, that vapor itself is reacting with the solution. Okay, so in that case we use reflux. The vapor, it is coming back to the liquid, so it is known as reflux. When phenol is refluxed with chloroform in the presence of aqueous NaOH. So first of all, we'll have.
This vapor is formed on reaction or while boiling?
Sorry, no, by boiling.
So,
By boiling, the vapor is formed, and that vapor reacts with the. One of the reactant here, it should be vapor form. That is why we boil it.
yes, sir.
Okay, so OH, and then we first of all have CHCl3 in the presence of NaOH. First of all, here we get ONA. because this is what basic condition. This hydrogen will be abstracted, it will be liberated, and then we will be getting CHCl2. Okay, this is the first. After this, now we still have what? So many NaOH, right? We still have NaOH. Now here we have 2 chlorines and 1 hydrogen. No? See. Chlorine, chlorine, and 1 hydrogen. So both of these chlorines, they are substituted by the OH atom from NaOH, and they are making NaCl. So we'll have ONA, and here the OH atom from here and the OH atom from here is getting replaced, and is substituting the chlorine atoms. Now, as you know, in 1 carbon we have 2. What in 1 carbon we have 2 hydroxy groups, and that is very unstable. So what will happen? One of them will leave and it will form aldehyde. In the first lecture, I have told this, that when we have 2 hydroxy groups in 1 carbon atom, it changes to what? Aldehyde. So I will be getting CHO, and then on further hydrolysis, that means in the presence of ONA H plus, we will be forming the phenol OH with a CHO. This is known as what? Salicylaldehyde. Okay, this is known as salicylaldehyde. So if you want to write the reagents here, so in the first step, we are using what? CHCl3 in the presence of NaOH. और देखिए temperature भी दिया इन्होंने 340 Kelvin. Okay, and after that, in the second step, we just want to add H2O in the presence of H plus. इसको workup बोलते हैं. Okay, so just now we have this word na reflux. So you will see in some of the books this word workup. After workup, we get the salicylaldehyde. Workup means adding of acidic water. पानी को ऐड करने के लिए वर्कअप बोलते हैं, short word उसका. And it is one of the very common reactions, very common step in synthesis. That is why this word workup is there. Similarly, reflux is also very common in synthesis. Write this down, then we'll look at the mechanism. These are just these steps, okay? These are just these steps. It's not the mechanism. The main step of mechanism is obviously this first step, how this CHCl3 is getting here. So look at that first. So please look at mechanism. Okay. Now in mechanism, the first step will be this carbon atom with 3 chlorines and 1 hydrogen. Now this all 3 chlorines are what? These 3 chlorines are electronegative, and 3 of them are attached to carbon atom, which is getting delta positive here, and that is where this carbon atom will be further attracting the electron from the hydrogen atom, right? So all of these chlorine atoms are helping in removing the electron density from the hydrogen atom. That is why this hydrogen here, it is basic in nature. Sorry, it is acidic in nature. That means it can be easily broken. This bond can be easily broken because it is very polar bond and it has delta positive charge here, and that is why this can break in the presence of any OH. That is our base. Right? We have OH negative. OH has lone pair electrons like this. This will attack on the hydrogen atom and leading to formation of carbon with 3 chlorines, a lone pair, and a negative charge. Okay. Now carbon is not an electronegative element. That is why carbon is not an electronegative element. That is why what will happen? This charge on carbon atom, it will be very unstable. It will be very unstable, and that is why, first of all, carbon pair we have, and there is a negative charge, 3 chlorine atoms. So what the carbon will do? Carbon will give the charge to what? Chlorine atom. Carbon will give the charge to chlorine atom, and chlorine will move away with a bond like this, leading to formation of carbon and 2 chlorines. I've given here, these are not lone pair, these are just free electrons, and these electrons are non-bonded electrons. Okay, these are non-bonded electrons, but it is not electron-rich species. Why it is not electron-rich? Because it has one bond, two bond. If we have two bond, each bond has 2 electrons. That means we have 4 electrons till now. 5th electron here and 6th electron here. Now this species is very special. It is what? Electron deficient. It is an electron deficient species, which is known as carbene. Okay, so this is the formation of carbene. Okay, so this is carbene. It is what? Electron deficient, electron poor. Okay, because the total number octet is not complete, incomplete octet. सब लिख लीजिए आप लोग, incomplete octet. बाद में फिर आपको सर पूछाइएगा कि सर यहाँ पे तो सर लोन पेयर है, फिर भी ये इलेक्ट्रॉन पुअर कैसे है? सब लिख लीजिए. We have 1, 2, 3, 4, 5, 6 electrons only. Okay, right? Now, in the presence of NaOH, our phenol will be changing to phenoxide ion, not especially carbene. बट ये मैकेनिज्म आप लोग बाद में देखिए ना. हम यही होप कर रहे हैं कि आप लोग बाद में ये मैकेनिज्म देखिए, है ना. उस टाइम अगर किसी ने दिमाग लगाया, उसको लग रहा होगा कि यहाँ पे here we will have phenoxide ion and we have bonds like this, and then this carbene atom, this carbene carbon Cl2 will come. Obviously this carbene is electron poor, so the benzene ring will attack like this. Now leading to formation of what? Leading to formation of this electron will bond will come here. We'll have oxygen atom here, and here we'll be getting carbon Cl2. Okay, there will be a bond here, there will be a bond here. Now it has got an extra electron. That is why what will happen? It will get a negative charge, right? Because see, the electrons are coming from, 2 electrons are coming from where? 2 electrons are coming from the 2 electrons are coming from the benzene ring itself. That is why it is getting a negative charge. And here I will be having a hydrogen. This hydrogen will be abstracted by the carbon because it has negative charge to get it neutralized. Because we know carbon is not an electronegative element. It wants to neutralize its charge as soon as possible. Negative charge especially. And once it is abstracting the hydrogen will leave the electron to the benzene ring. This pi bond will break and we'll get again O negative. So we'll get here O negative. And this O negative is also bonded with Na. We are not showing that here. And you don't need to show that here. And we'll be getting here CHCl2. Now the next step of the reactions are very easy. You just need to replace the chlorine atoms with OH, because that is what NaOH does. I can make a ring here, and it is still O negative. And here I will be getting CH and OH whole twice. And when we have a gem diol type of situation, we get an aldehyde. And this is a gem diol type of situation. O negative, here I will be getting CHO. And then on further H plus, I will be getting salicylaldehyde. So this is also an example of electrophilic aromatic substitution reaction, because this is what? Electrophile. Okay, this is also an electrophile. Whatever mechanism, whatever reaction we do in a class now, please try
Sir?
to tell me. Do them once
Sir,
again
can
in your
you-
home.
So can you explain from the 4th step?
1, 2, 3. This one.
Yes, sir.
Okay. Here we have Na plus, na? So Na plus is reacting with this chlorine atom here, and it is taking away the chlorine atom. That is it. Nothing else is happening here. Okay. And then 4th to 5th is the 2 chlorine atoms has been taken by Na plus. So Na plus की जगह क्या आ जाएगा? OH negative आ जाएगा. You have the Cl will leave as Cl negative, so OH negative will come and attack here. Okay. Then the next step is what? Actually, what happens here is, see, this carbon is having 2 chlorine atoms, so delta positive. OH has lone pair electrons, that means electron rich. So it will attack here. As soon as it will attack here, this chlorine is a good leaving group, है ना? Chlorine is a good leaving group, right? अरे अपने reaction नहीं देखा है क्या? Cl plus NaOH क्या होता है? देखा है नहीं देखा है मोहम्मद उमर?
Yes, sir.
क्या? You remember it now?
Yes, sir. Yes, sir.
ठीक है, अब देखिए Next आपका क्या है? Then we have gem diol. Have you seen this situation? Carbon with two hydroxy groups. It converts to aldehyde. You remember it? You do not remember it. Tell me.
Which one?
This carbon with two hydroxy group, it changes to aldehyde. You remember it? You don't remember it.
I guess I don't remember it.
ये देखिए, याद आया? One carbon atom,
Oh, okay.
first class. More than one OH group cannot be present in one carbon atom as the molecule becomes very
Hydrolysis.
unstable and releases H2O. Okay?
Hydrolysis, right?
No, not hydrolysis. यहाँ तो hydrogen water निकल रहा है यहाँ से. This is dehydration. So here the water is going to release from here. Okay? Because carbon
What's the
atom
reagent?
connected to
Reagent
tell me.
used.
No, nothing reagent is used. It is intramolecular only. See, one molecule itself is getting reacting here. Okay. So actually what happens here is this oxygen atom, it attacks on this hydrogen because there is a very strong hydrogen bonding here. And once it gets attached to this hydrogen, this oxygen will get a positive charge. Once it gets positive charge and it has two hydrogen atoms, it will leave as H2O. Okay. Nothing else. And when this hydrogen will leave, since here you can see it is getting electrons from the oxygen atom, this hydrogen will leave the bond here, making aldehyde. It is intramolecular. One molecule in itself goes through a change. No reagent is required. Okay. Right next for ethers.
So can you zoom out?
You want to take a screenshot?
Okay, I will take a screenshot.
The main thing is that for you, for CBSE, you have to remember the reagents. Okay, chloroform, aldehyde, carbon dioxide. Carbon dioxide will give you what? Carbon dioxide is going to give you carboxylic acid, salicylaldehyde. No? The two reactions, Kolbe and Remer-Team. Kolbe mein you use CO2. Remer-Team we use CHCl3. Done.
Yes, sir.
Okay. Right next, ethers. Okay, what are ethers? Ethers are also known as alkoxyalkane. Okay, now I'm just revising a bit from the nomenclature. Let us suppose you have something like this. So here you have to take that carbon atom, which is longest, right? So this will be your parent carbon. And this is what? This is parent carbon. And this part will be what? Ethane. And this is one carbon atom. This will be methoxy, including this hydrogen oxygen atom. This whole substituent is what? Methoxy. So we will name this as, so you can number 1, 2, 1 methoxy. Methane. But if you have a situation like this, let us suppose 1, 2, 3, 4, 3 carbon atoms, let us say, and here we have only 2 carbon atoms, but this 2 carbon atom has a OH group. Now here, since we have a functional group in this side, on the right side, this is going to be our main chain, and this will be what? 1, 2 carbon. That means we have ethanol. Okay, so we'll write 1 carbon for the OH hydroxy. We start numbering from that carbon atom which is nearest to the functional group, from that terminal carbon atom which is nearest to the functional group. Okay, so we'll start 1 and 2. In the second position, what do we have? This whole substituent in which we have 1, 2, 3 carbon atoms and then oxygen atom. So this 3 carbon atom will be propoxy. Okay, so the name will be, since propoxy is in the second carbon atom, it will be 2-propoxy. Ethane 1-ol or ethanol. Got it? Yes or no? You have to first of all identify which is the parent chain, either the right side of the oxygen or the left side of the oxygen, which is the parent. And once you have identified the parent, that will be participating in this alkene part. Okay, so you'll not get this ethanol type of thing. You will majorly getting this type of questions. And then write one more thing regarding if you have something like this. Take my bad. Thank you. Please change this to ethane. I have wrote methane here also. Methoxyethane it will be. Thank you, Muhammad Umar. Okay. Now, if you have something like this, let us suppose we have a benzene ring and then we have oxygen atom and then we have R. That means this is what? Now you have to see what, let us see if you have something like this. OCS3. If you have OCS3, then it is what? Methoxy. Benzene. Methoxybenzene, it is also known as anisole. Okay, like we have phenol, we have halorine, we have benzoic acid, we have benzaldehyde. This is anisole. That like we have aniline, this is anisole. Okay, in general. If you have O, and then R, this is alkoxybenzene. Alkoxybenzene. Okay, this is also sometimes known as alkyl phenyl ether. Alkyl phenyl ethers. That is one of the common names, by the way. So also known as alkyl phenyl ether. Okay. Write a few more. For example, if you have this example we don't know, to methoxyethane, it can also be known as ethyl methyl ether. These are common names. Okay, these are common names. Ethyl methyl ether. Then if you have, let us say, 2 carbon atoms, then it is known as diethyl ether. It is also known as what do we have? Ethoxyethane. Okay. So just a slight introduction. We have, because we have done already nomenclature in like when we were doing the alcohols, no? We have done the nomenclature at that time also. Okay, I think this is enough. Write the method of preparation of ethers next. Method of preparation of ethers. Okay, so for this you will write number 1. Dehydration of alcohols. Number 1. Dehydration of alcohols. Please write these things with me, okay? Dehydration of alcohols. Number 1, we have already seen dehydration of alcohols, but we saw that it was forming. बोलिए.
Can you scroll up?
अरे बहुत देर कर देते आप तो स्क्रॉल अप बोलने में हम यहाँ पे स्टार्ट कर देते टॉपिक. What has happened? हाँ, आदत छोड़ दी है आपको पढ़ने की मोहम्मद उमर.
Yes, sir, done.
Done. Okay.
Yes.
Dehydration of alcohols. So we have already seen dehydration of alcohols, and it was giving us alkene. So we had CH2, CH2OH, and in the presence of H2SO4, at somewhere around 443 Kelvin, we were forming CH2 double bond CH2 via elimination. But if we have a lower temperature with same reagent H2SO4, but we have 413 Kelvin, then we are going to get CH3, CH2. Okay, so this CH3, CH2, O, and then CH2, CH3. So we get alkene at 443 at higher temperature, and we get ether at lower temperature 430. Because at higher temperature, the bond breaking is very much easy. So more bonds break and we get what? Alkene. But at lower temperature, substitution is favored. So this is elimination. Example of elimination reaction, and this is an example of substitution reaction. Okay. Substitution reaction. Please make symmetrical ethers can be prepared by dehydration of alcohols with concentrated H2SO4 at 413 Kelvin. I used to remember it as 414 because 414 kind of looks like ether. Okay. So मैं 12th standard हमने 414 याद कर लिया था क्योंकि 414 थोड़ा ether की तरह दिखता है. 414 ROR. If you want, you can learn it like that. I think this question came, but I think I've wrote this also in some test, if not board exam, 414 Kelvin, and I don't think कि marks कटा था वहाँ, because 413 and 14 क्या ही फर्क पड़ता है 1 डिग्री सेल्सियस से. उतना एक्यूरेटली तो मेंटेन करना भी मुश्किल होता है टेम्परेचर को. Okay, so we can only make symmetrical ethers. There are many things about this reaction that we are going to learn about it. Okay, so first let us look at some of the examples, and you please draw the examples right here. Example. For example, if we have, let us suppose CH3OH, then in the presence of H2SO4 at 413 Kelvin, it is going to make CH3O, CH3. Okay, similarly, if you have OH at the same conditions. So here we have 2 carbon atoms, 1, 2, and the next bond will be with oxygen, and then again 2 carbon atoms. OH. Generally ये reaction करते नहीं है. We usually use 1 degree. वो बताएंगे क्यों. For example लिख लीजिए इस तरह से. So here we have 3 carbon atoms, 1, 2, 3 carbon atoms. Next one will be with oxygen. Then again 1, 2, 3 carbon atoms. Right, next mechanism. So in mechanism, we'll be explaining this reaction. CH2, CH3 single bond CH2, single bond OH in the presence of H2SO4 and 413 Kelvin. We are going to get 1, 2 carbon atom and oxygen, and then 1, 2 carbon atom. Okay. So the first step will be protonation of alcohol, in which we have the ethanol plus H plus. We have lone pair electrons in the oxygen atom. This H plus is electron poor. It will attack like this. So protonation of alcohol, we are forming hydrogen, 1 more hydrogen, and then a positive charge here like this. Now in the next step, what will happen? The attack will happen. So we'll have some more ethanol like this. Not all the ethanol at same time will get protonated. Some of the alcohols will be unprotonated, and we have this protonated alcohol. Now, since the temperature is not as high, there will not be so much banging that each and every step should be making some product. And if there is not so much banging between the molecules, they're not colliding so much. So what can happen? This oxygen atom can attack onto this carbon atom. And because this carbon atom is delta positive, because this, see, यहाँ पे oxygen पे attack नहीं करेगा, because oxygen has already too many electrons. See, oxygen had how much electron? ये एक तो bond जो था lone pair वाला, this blue bond, it has made a bond with hydrogen, but these electrons are still there. Okay, so if you count the number of atoms in oxygen, it is 1, 2, 3 bonds. That means we have 6 electrons, and then here we have how many? 2 electrons. That means 8 electrons in total. So we already have complete octet. It is just a formal charge that you have learned in class 11. Okay, it is not a pure charge. It is not a real charge. It is formal charge. And this formal charge, what it is doing, it is making the oxygen atom positive charge here, and oxygen atom is furthermore pulling the electrons from the carbon atom. Okay, and once it pulls the electron from carbon atom get delta positive charge, and then this oxygen atom attacks onto this carbon atom, and this will leave as a leaving group. So this attack is like SN2. Okay, so this is like SN2 mechanism, and we are going to get oxygen, and these 2 carbon are as it is. Okay, after that we are going to get a hydrogen here. Okay, so this oxygen attacked onto this carbon atom. ये blue carbon पे attack किया, ये blue carbon के साथ bond बनाया, and then here we have one more carbon atom. So this one more carbon atom is here. I hope you can see all the carbon atoms, and this is now getting a positive charge. Now, as we have got the H plus here, the H plus will be then going away, giving its electron to the oxygen atom. This is deprotonation step. If you will ask now, sir, why a deprotonation हो कैसे रहा है? So see, H2SO4 will give you what? H plus SO3H negative, right? Now this SO3H actually attacks onto this H plus ion. Okay. SO3H जो यहाँ पे है, that attacks onto this H plus ion and it abstracts away. So minus H plus. So H plus added and H plus is away. So it is used as a catalyst. It is taking part in the reaction, but it is not getting consumed in the reaction. Okay. Write some remarks. Point number 1, the acidic dehydration. Of alcohols to form ether occurs via SN2 mechanism. Occurs via SN2 mechanism. The next one. The reaction is also accompanied with formation of some amount of alkenes, because always it is a competition. Okay, so some amount of alkene will always be found, not 100% will be getting ethers here, because some elimination can also happen. It is always a probability type of thing, which is more dominant and which is lesser dominant. It is never absolute in terms of organic chemistry. Okay, so some amount of alkene will also be found, but majority of the component that is found here is ether. Okay, also coming by the formation of some amount of alkene. Okay, right. Next, this method is only suitable to form symmetrical alkene. Symmetrical alkene using primary alcohols. Why only primary alcohol? Because it is SN2, and in SN2, what is fastest? The primary alcohol is reactive towards SN2. Okay, right. Next, 2 degree and 3 degree alcohols tend to form alkenes as they are more hindered. Okay. Right. Next, order of dehydration. In order of dehydration, we have seen two things. So for both of them, right? Number one, to form ether. To form ether, it is via SN2 mechanism. That is why 1 degree is fastest, followed by 2 degree, and then followed by 3 degree. If I look at to form alkene, 3 degree is fastest, followed by 2 degree, and then followed by 1 degree. It is via SN2, and this is happening via E1 mechanism, in which we form a carbocation, if you remember the dehydration to form alkene. Okay, so this is the order of dehydration for ether, and that is for the alkene. They are more hindered. Spelling they are more hindered. If it is hindered now, if the alpha carbon, the carbon containing the hydroxy group is hindered, that means it will be not attacked by the another alcohol. Why? Because it is hindered. And if it is hindered, what the alcohol will do? Alcohol will see that, okay, I can attack the hydrogen atom of the adjacent carbon, so it will attack the hydrogen atom of the adjacent carbon and forming alcohol. It will not attack the carbon of hydroxy group, carbon containing hydroxy group. Okay, now let us explain why we cannot form unsymmetrical alkene. Okay, so let us suppose we see unsymmetrical alkene, something like this. Okay, now we have two components here. So this component here, this can be made by 2 carbon atoms. So we can get this from this alcohol. And here we have only 1 carbon atom. So this can be from CH3OH. Now when I mix them in the presence of H2SO4, let us suppose, 413 Kelvin, H2SO4. Now, see, here we have ethanol and here we have methanol. Okay, so the idea is not all ethanol will be knowing that there is an ethanol present. Yes or no? Please tell me, guys. Like there will be million molecules of ethanol. Not all ethanol will be surrounded by methanol. Na? Some ethanol will be there with their own group, right? Some ethanol will be there and they will not know that there is ethanol present in the solution also. Is that right? Yes or no? Please tell me.
Yes, sir.
Right, and also they will be colliding with, let us suppose the probability is that what, 50-50%. The ethanol here, it can collide with other ethanol molecules and it can also collide with other methanol molecules. So let us suppose what is going to happen if it collides with another ethanol molecule. If it collides with another ethanol molecule, it is going to make simply diethyl ether like this. Similarly, there will be some ethanol which will not be knowing that there is ethanol present in the solution. They will be colliding with the methanol molecules only, forming CH3O, CH3. And then there will be some ethanol, and then there will be some methanol who will be knowing that, okay, fine, ethanol is also present. This ethanol will be knowing, okay, fine, methanol is also present. They will be colliding with each other, forming to get our target material. This is. Now, we are getting a mixture, right? We are getting a mixture. We can, if I talk about probability, then we can say that there is 33% chance here, right? So here we are getting how many carbons? 4 carbon atoms. Here we are getting 2 carbon atoms. Here we are getting 3 carbon atoms. All of them have similar number of carbon atoms, and there is 1 oxygen in all of them. That means the molar mass also will be very much comparable. If the molar masses are comparable, that means they will not have a very big difference in the boiling point. If they don't have a very big difference in the boiling point, then we cannot do steam distillation. If you remember, the distillation can only be done if there is a difference in the boiling point. They have similar molar masses, they have similar boiling points, so they cannot be distilled and they cannot be separated. That is why we don't use this method in order to make unsymmetrical alkene. Okay, so we'll write this. Please write the point. This method is not suitable to form. This method is not suitable to form. This method is not suitable to form unsymmetrical ethers. alkene बोल देते हैं हम कभी-कभी इसको. Unsymmetrical ethers, as it would give mixture of ethers difficult to separate. Okay, so I hope you understand each and every line. Why it is difficult to separate also. You can write the same example here. OH plus CH3OH, H2SO4, 413 Kelvin. Write it fast. Okay. Let us start. Next method of preparation from alkyl halides. Okay, this is also Williamson. This is very important. Williamson ether synthesis. Williamson ether synthesis. Please write. When haloalkane is treated with, when haloalkane is treated with when haloalkane is treated with suitable sodium alkoxide, so how is sodium alkoxide prepared? It is prepared by reaction of alcohol with sodium. Okay, alcohol with sodium. With suitable sodium alkoxide, an SN2 reaction takes place. Forming corresponding ether. Let's suppose that we start with the alcohol like this, ROH. Please see very okay, please see here, don't write anything. ROH and Na. I hope you remember this reaction. It will give you RONA plus H2 gas. Okay. Now this RONA is going to react with RX, alkyl halide. Now this alkyl halide here will be getting delta positive. And here we have lone pair electrons on oxygen atom. It will attack onto this R, and this X will leave on the same step. And since here you can see the attack is happening on the alkyl halide, so this alkyl halide should be what? It should be not hindered. Okay, it should not be hindered. It should be preferably a primary alkyl halide. Okay, RONA. Okay, R dash, please, sorry, R dash, so that we will be getting RO, R dash plus NaX. Okay, now this we can use any type of combination in order to make the product. So basically what is happening, you have RONA plus XR, and this NaX is getting bonded. Right, these two bonds are breaking, and we are getting R O R dash plus NaX. है ना, यहाँ से आप क्या कीजिए, इस बॉन्ड को लीजिए, यहाँ से इस बॉन्ड को लीजिए, मिला दीजिए. This bond and then this bond, and then NaX is going to be formed. Right remarks. Since Williamson's ether synthesis occurs via SN2 mechanism, the alkyl halide should be preferably primary alkyl halide. Okay, preferably primary alkyl halide. For the formation of unsymmetrical alkene. For the formation of unsymmetrical alkene. So question इस तरह से आएंगे आपके पास. Write the names of reagent and equation for the preparation of the following ethers by Williamson ether synthesis. Okay. So in that, these are very easy. First of all, you make the number one, the ether, propoxypropane. So 1, 2, 3 carbon atoms bond with oxygen, and then 1, 2, 3 carbon atoms. Now, since this is a symmetrical, it is symmetrical ether. Then what you are going to do? This arrow here, it tells you about retrosynthesis. Okay. That means what are the reagents and what are the substrate that we can have in order to get this ether. To get this ether, we need 1, 2, 3 carbon atom, ONA plus 1, 2, 3 carbon atom, some halogen, let us say Br. If you will react this, then you are going to form what? You are going to form propoxypropane. Doesn't matter. So this fragment here, it is coming from alkoxide. This fragment here, it is coming from the alkyl halide. You can choose any one of them. Both of them are same. No issue here. Let us look at the next one. Ethoxybenzene. So we have a benzene ring. You have O, CH2, CH3. We have to just remember that the alkyl halide should be primary. Preferably, it should be primary. That means it should be less hindered. So we have two different types of two different fragments, I can say. Let us say this is the first fragment and this is the second fragment. So tell me, alkyl halide will be made from 1 or 2? Alkyl halide should be made from 1 or 2. Write in chat. Please write in chat. You have to choose alkyl halide kisse banana hai. From the benzene ring or from the ethoxy group? From the 2 carbon atoms jo hai. 1 or 2. Khalil, correct. Samira,
Sir,
correct.
can you repeat again?
Which fragment here? Sir, देखिए. Can you see that this fragment here, it is coming from यहाँ से? Okay, so similarly, I'm asking which of the fragments? This fragment, okay, इधर वाला fragment या फिर okay right side वाला fragment? Which of the fragments will be used in order to make this ether? Alkyl halide कौन से fragment से आना चाहिए? From the first fragment or the second fragment? Which is less hindered. You have to look at the carbon atom which is connected to oxygen. So you look at this carbon atom and you look at this carbon atom and tell me which is primary. Which carbon atom is primary? Nabil, correct. Matthew, you want to change the answer?
Yeah.
Okay. So I hope you can see. What about others? Huh? बाकी लोग का तो नहीं आ रहा है जवाब. Astha, tell me what happened. Confused.
Yes,
Astha.
sir. Sir, I'm writing the question. Okay,
Question क्यों लिख रहे हैं आप? Question क्यों लिख रहे हैं? Question अभी मत लिखिए ना. अभी आप जब यहाँ टीचर बात करता मत लिखिए आप. ठीक है? अभी मत लिखिए question. Question is important नहीं. ठीक है? What did I ask? सुना भी नहीं आपने. Astha?
Yes, sir.
What did I ask? Did you listen it?
No.
Okay.
Sorry.
What about others? Hania, Hishma, Nawal. Hania, tell me. Done. Hania, can you please turn your mic on? Done क्यों बोल रहे हैं आप? हमने लिखने तो इन्हें बोला था. Hania, I'm asking some question. ये बच्चे जो हैं लिख. अरे समझिए पहले समझिए. आंसर बस आप लोग छाप दीजिएगा इसका मतलब. ओके, आस्था सी. हानिया, व्हाट हैपेंड? प्लीज कैन यू आंसर? आप लोग म्यूट करके क्यों रहते बैठे हुए? This thing makes me angry. Astha, can you listen?
Yes, sir.
So Astha, I'm asking here. Did you see how did I make this? And what is this arrow? कुछ नहीं सुना आपने?
नहीं.
अरे सुनिए भाई, यहाँ क्यों आए हैं? नोट्स आपको रिकॉर्डिंग सब कुछ मिल जाता है. ठीक है, बार बार सुनिए. This arrow here, it tells you about retrosynthesis. ठीक है, ये ईथर किससे बन सकता है? Got it, Astha?
Yes, sir.
Reaction counter. ठीक है, reaction counter. So this is called as retrosynthesis arrow. You don't have to know about this, but it is easier to denote with signs and all. Okay, that is why I've just told you. This is the retrosynthesis arrow. Okay, and This ether can be made by reacting this alkoxide and this haloalkane, correct? Yes or no, tell me.
Yes, sir.
See, every
Yes.
ether will have two fragments, right? One of this fragment will be coming from alcohol, the other fragment will be coming from alkyl halide. But if you have written the note, then you will see that the alkyl halide should be what? Primary, secondary, or tertiary? The alkyl halide should be
Primary.
primary. अब इस वाले सवाल में आप बताइए. We have this fragment, the first fragment, right? This R part, either this can come from the alkoxide or this second one can be coming from alkoxide. But we have to first of all see which is coming from alkyl halide. Now you have to look at the carbon atom that is connected to oxygen. Look at the green carbon atom and the blue carbon atom and tell me which is primary, green or blue? Which is primary? Which is primary? जल्दी बताइए. Green or blue, दो कार्बन है. Which is primary? Do you know what is primary, Astha?
First, I mean second carbon is primary.
You say first one, but you mean second carbon atom. Okay.
No, sir, second carbon. It's attached to 1 degree carbon, so it's the primary.
It attached to only one carbon. Yeah, correct. CH2, CH3, CH2, and then we'll give a Br here. Plus, if I react ONA, this is our preferred reagents. Okay, preferred substrate in order to get what? In order to get this type of ether. Now look at the next one. 2-methoxy, 2-methyl propane. I have some question. Okay, Salman. 2-methoxy, 2-methyl propane. So we'll have propane 1, 2, 3. We have got propane. Let us see 1, 2, 3 and 2-methoxy, 2-methyl, and we have OCH3. So we have 1, 2, 3 carbon atoms, 1 methyl group here. So we and 1 methoxy group here. Okay. So 2-methoxy, 2-methyl propane. Now you tell me here. We have this green carbon atom, and then here we have the blue carbon atom, which is primary. And how are you going to make the which is going to be alkoxide, which fragment is going to be haloalkane? I think this is very easy. Tell me, guys, 1 or 2, which is going to be alkyl halide? Please write in chat. Which is going to be alkyl halide? Hania, do you understand? क्या पूछ रहे हैं हम? नहीं पूछ रहे हैं, आप जवाब ही नहीं दे रहे हैं. Hania.
Yes, sir.
Yes, correct. Are you listening? What I'm asking?
Yes. Yes, yes, sir.
क्या पूछा हमने? बताइए. Yes, आस्था correct. नबील correct. Yes. हाँ नबील ठीक है भाई. ठीक है. इंडिया जीत गया. ठीक है, I know that. पूरा blue कर दे रहे हैं आप. Yes, Nabil Khan, very good. You have started to answer. Nawal, very good. Hania, हमने क्या पूछा? कौन बनेगा करोड़पति में सवाल आया कि सवाल क्या है? जी बताइए हानिया. What did I ask?
Sir, your voice is breaking. Can you please ask again?
Okay. इससे पहले का कुछ आपने सुना?
No, sir.
पागल हो जाएंगे फिर तो
Wait,
भाई.
I'll.
चलिए ठीक है. I hope everyone has got this, that we are going to make CH3 and Br or any other. You also use Cl here. No problem in that. हाँ correct Matthew. क्या हुआ Matthew? बहुत टाइम लग जा रहा है आपको जवाब देने में?
Sir, I sent it a while ago. I think I sent the wrong ID. That's it. I realized I sent it the wrong ID.
Okay. ONA. Okay. And the next fragment will be ONA. Then we have methoxyethane, fourth one. Methoxyethane, CH3, O, CH2, CH3. Right. Now tell me which is primary. This one carbon or the second carbon, which is primary? Which is primary, tell me. Okay, Hishma, you are not answering. What happened, Hishma? Can you hear me?
Yes, sir.
क्या हुआ? आप आंसर नहीं कर रहे, बिल्कुल नहीं समझ में आ रहा आपको? Yes, Hishma, tell me. फिर से explain करें?
Sorry, sir.
Should I explain it once again?
No, I'm getting.
Why you are not giving answers then? ये तो जितने also one more thing. Those of you have written one, na, that is wrong. One is not primary. One is not primary, okay? 2 is primary, but again, we are going to do this. We are going to do this reaction from unhindered carbon. So the more unhindered carbon is this carbon atom, CH3, okay? So CH3Cl, preferably, यहाँ पे we both have 1 degree. This is 0 degree, rather, this is 1 degree. You can use any of them for alkoxide and any of them for the haloalkane, but preferably I will be using this because it is even less hindered, and I will have CH3, CH2, ONA. Okay. So whatever is less hindered, that we have to use. Generally, it is primary alkane halide. Okay. Now, please remember, इसमें आप ये भी बना सकते थे, इसमें भी कोई दिक्कत नहीं है. CH3, CH2, Cl plus CH3, ONA. This also has no problem here. Okay, because both of them are comparatively less hindered. No, Muhammad Umar, this is all from the class that I have just taught. यहाँ पे remarks लिखाया था हमने. Since Williamson ether synthesis occurs via SN2 mechanism, the alkyl halide should be preferably primary alkyl halide for the formation of unsymmetrical alkene. And we are forming some ethers, and I am asking what are the reagents that we should have. Now, each and every ether, it is composed of 2 alkyl groups. One of the alkyl group, it comes from haloalkane, and the other alkyl group should come from alkoxide ion. And we are predicting what are the alkoxide and what is the alkyl halide that we have to. Now, for alkoxide, we don't have such a rule, but for haloalkane, we have a rule that a less hindered carbon should be chosen as the haloalkane. And then we are looking at the fragments and then predicting which is haloalkane. Okay. Right, next. Right, next point, which is important. Usage of 2 degree or 3 degree alkyl halide leads to formation of alkenes as they are more hindered. So let us suppose we have CH3 ONA plus we have a haloalkene like this. I'm making all the hydrogens here because I need to make that. And let us suppose Br here. Now, see, in order to make ether, the attack should happen like this in this carbon atom. But since this is CV, we have 3 carbon atoms, right? It is very hindered. This attack does not happen. Okay. Rather, what attack happens? This oxygen's lone pair electron, it attacks onto this hydrogen atom. This hydrogen atom, it gets subtracted and then it gives the electron to this bond, and then the Br is left. So this is elimination reaction, as we have seen earlier also in haloalkane halorine chapter, right? Beta elimination. So the beta carbon, see, this is alpha carbon, beta carbon ye hai, beta mein we are getting hydrogen. Okay, the hydrogen is getting abstracted. So we are going to get 1, 2, 3 carbon atoms, 1, 2, 3 carbon atoms. Then this hydrogen is giving a double bond, so there will be a double bond, and this carbon atom, there is carbon atom, 1 hydrogen has been taken away, so we will be getting only 2 hydrogens, CH2, plus this Br has left, this Na will come and attach to this Br, NaBr. Now we have the CH3O. The CH3O has attached to, it has attacked on the hydrogen atom. That is why we will get CH3O and then the hydrogen atom. So these are the product that is formed if we use 2 degree or 3 degree alkyl halide. But if we want to make some ether, then what we have to use? We have to use a reagent like this. ONA plus CH3Br. Now this CH3Br, it is very easy to attack here onto this carbon atom, the alpha carbon atom. Okay, and once this is attacked, this Br will leave, and we will be getting 1, 2, 3 carbon atoms, O, and then CH3 plus this Br will be getting away with Br negative, Na will come and it will attach with itself. It will be getting NaBr. Hindered है ना नबील? See, ये तो ऐसे बस आपको दिख रहा है, but if you will look closely ना, it is having see carbon atom and hydrogens here, carbon atom and 3 hydrogens here. Yes, Asta, tell me.
So when we like draw mechanisms and all in exams, is this arrows and all compulsory?
हाँ. Mechanism, it means you have to show the arrow.
Okay.
You have to show only the green arrow यहाँ पे जो है. Okay, the one I made ना, this attack was what we thought that it will be happening, but this is not going to happen because it is hindered. ठीक है?
Okay.
You don't have to make the red ones. जो attack हो रहा है बस वही दिखाना रहता है. Nabil, you understood why we are not going to the red route?
Yes, sir.
Yes, Nabil? Okay, fine. Okay, and that is why we use what unhindered alkyl halide, and this alkoxide and ion can be hindered as it. I mean, जितना भी आपको hindrance में डालना है, ठीक है? Right, next. For the formation of alkoxybenzene, haloarine and alkoxide cannot be used. Alkoxide cannot be used as haloarenes. See, यहाँ पे we have to break the C-Br bond, okay? The carbon and halogen bond. As haloarene show resonance, and the CX bond has partial double bond character. Which is difficult to break. Okay, that is why if I use Br plus any RONA, then this reaction does not happen. What we have to use? We have to use the phenoxide ion, ONA plus RBr, and then we are going to get OR, alkoxybenzene. Rather, phenoxide ion and alkyl halide is used. To form alkoxybenzene. Okay, next class में ये chapter खत्म हो जाएगा. So I just wanted to ask you guys, okay? I wanted to ask you guys. Next chapter कौन सा लेना चाहिए? ठीक है? Next chapter कौन सा लेना चाहिए? First write this down, then I will give you some options. Devangi will be starting in a few minutes, okay?
Yes, sir.
Done, guys? Tell me. Saif, Omar, Nabil, Khalil. Tell me,
1
guys.
minute, sir.
Done. 1 minute.
Yes, sir, done.
What about others? Is there anyone who's still writing?
Done, sir.
No, sir.
Done, no? Okay. Choose one now and send the answer in chat. एक और ऑप्शन दे देते हैं. Okay. A is winning, by the way. A is winning. A is still winning. मोहम्मद उमर, आप एक बार कर दिए बस काफी है, ठीक है? जो एक बार कर दिया वो ना करे फिर से, बदमाशी नहीं. ठीक है. So let me see. 1, 2, 3, 4, 5, 4. मोहम्मद अमीन 2 बार दिया. 4, 4, 4, 5, 6, 6. 6 vote is for aldehyde ketones. I think that is Anya. What is your preferred chapter then? If not anything, Anya ने D लिखा है.
I'm not
Anya?
sure, sir. We've only completed 3 chapters in school.
What 3 chapters? Tell me. Till alcohols.
Yeah.
So I think they will be going for aldehyde ketones, by the way. Okay. Saf is saying D and F block. Saf, आपको बस एक ही vote मिला, I think. And who else? B is with Matthew. Nawar is saying B, and we have Nabil who is saying B. Okay. Khalid is also. Khalid, you are saying B. Khalid or Saman?